How's it going, geometry people? Today we are talking about 4.4 using corresponding parts of congruent triangles. Whew, what's that mean? Okay, the CPCTC. This stands for corresponding parts of congruent triangles are congruent. What's that mean? Well, the CPCTC is used in proofs to show pieces of congruent triangles are congruent. Okay. So what you're going to do first is you're going to prove two triangles are congruent, and then you have to say, since those two triangles are congruent, you know these two sides are congruent by CPCTC. Whew, try saying that 8 times fast. Okay. So we're going to move on. Ready? Ready? Developing a proof. Okay, first we have to state why AXY and CYX are congruent, unless all corresponding parts of the triangle that are congruent. Okay. Oh, come on, Moby. So this is going to be a little bit trickier because this picture has overlapping triangles, which always makes it a little bit difficult to see what's going on. So triangle AXY and CYX. Well, I can see angle A is congruent to angle C because they have the mark, right? And I can see angle AXY is congruent to CYX. Okay, and that's because it's marked. And I can also see that AX, the segment, is congruent to CY because they're marked. So we have an angle, a side, and an angle. So the two triangles are congruent. They're congruent by angle, side, angle postulate. Okay? So we have, looks like 1, 2, 3 things listed, but we need a bunch more. Now, according to our corresponding parts of congruent triangles are congruent, if these two triangles are congruent, so are the corresponding parts. This is where it gets tricky. I'm looking at this whole segment, AY. That tells me AY is going to be congruent to this whole thing over here, right? Is going to be congruent to CX. Okay? Let's get the segments out of the way. Well, this guy at the bottom. Yeah. What about XY? It's congruent to YX. And that we could have proven by our good old reflexive property, right? Now we're still missing one piece. We need 6. Now this is a hard one to see. This angle right here is part of that triangle. That is angle AYX. And that's going to be congruent to angle, well, I'm looking at the smaller one now, CXY. Okay? If you ever get stuck, don't be afraid to redraw out these triangles. And then, you know, then when you, whoa, that's not good. And then when you go through the angles, you can see these two match up, these two match up, these ones match up, right? Another way to do it. Okay, proof time. Okay, my statements, my reasons. Put a box in here. Okay, first thing we always start off with is our given, right? Easiest points in the world. Just go ahead and write down what's given to you and write given. There you go. Okay. Now we need to get angle C is congruent to angle E, and we're going to need to use CPCTC to get there because, well, that's what this section's about. So first thing I need to prove is that these two triangles are congruent. Okay, so far I have two sides but nothing else, so that won't get me anywhere. I'm going to have to get an angle or the third side. Third side, I see there's nothing here to do. But if I look in here, I see a bow tie. And bow tie angles are congruent because they're vertical. So I know angle CAD is congruent to angle, well, EAD by depth of vertical angles. Or vertical angles are congruent. Okay. So now I have a side, an angle, and a side. That is pretty sassy. So I can state triangle CAD is congruent to triangle EAD by side, angle, side postulate. Now, if both these triangles are congruent, that tells me all the corresponding parts are congruent. So I can say now the angle C is congruent to angle E by CPCTC. Corresponding parts of congruent triangles are congruent. Okay? Corresponding parts of congruent triangles are congruent. One more time. Corresponding parts of congruent triangles are congruent. Phew. One more proof, guys, and we'll call it a day. Okay, so again, put my statement, my reasons, make a box. Okay. Again, easiest points in the world. And M is midpoint of BC. So it was a long time ago because it was BC. There we go. Okay. And I want to prove that AMC is congruent to AMB. Now those aren't vertical angles, so we can't go that direction. So we're going to have to prove that these two triangles are congruent and then use CPCTC. Okay. Well, what's it? We have to use some of this information. What's it mean to be a midpoint? Doesn't it mean that these two pieces will be congruent? Why, yes it does. I'm going to say BM is congruent to CM. M has to be second on both. By depth of midpoint. Okay? So now I have two sides. I need to get an angle somewhere or the third side. Luckily they share this side. So I can say AM is congruent to MA by the reflexive property. Again, reflexive is going to come up a lot, right? Now, if I look at my triangle, I have a side, and a side. I didn't make an AM joke about the morning. So I can say triangle AMB is congruent to triangle AMC, American Movie Classics, by side, side, side postulate, right? Now, since these two triangles are congruent, I can say all the corresponding parts are also congruent. Okay? So, that means that every angle has to be congruent. So that means these guys have to be congruent, right? In fact, they'd also equal 90. We'll say that for a different day. So I can say angle AMB is congruent to angle AMC by CP. Corresponding parts of congruent triangles are congruent. And then I'm done. That's it, guys. But guess what? If you haven't figured out by now, there's going to be proofs in this guy. Okay? Feel free to ask questions. Enjoy!